Hello and welcome to TranslatorsCafe.com channel. In this video we will talk about numbers. We will discuss different number systems and classification of numbers, as well as some interesting facts about numbers. A number is an abstract mathematical concept that represents a quantity. It is used in counting. Numbers have been used from ancient times, first in the form of tally marks. Tally marks are scratches on wood or bone. Later, numbers were used in more abstract systems. There are several ways of expressing numbers in numeric systems. We discuss some of them later in the video. These systems evolved over time. Some systems were replaced with newer ones. Some of the systems we look at are not in use today. Some researchers believe that the concept of numbers was created independently in different regions. The original written representations of numbers through symbols evolved independently. Once trade across countries and continents became widespread, people learned and borrowed from each other. Thanks to this, the number systems currently in use were created as collective knowledge. The Hindu-Arabic numeral system is one of the most widely used in the world today. It was originally developed in India and improved by the Persian and Arab mathematicians. In the Middle Ages, this system spread to the Western world through commerce and replaced the Roman numeral system. It was further modified and widely adapted around the world because of the European trade and colonization. Originally, the Hindu-Arabic numeral system was used in monasteries across Europe, but later it became used more widely in the society. It is a base 10 system, meaning that it is based on multiples of 10. It uses 10 symbols to represent all numbers. 10 is a common number to use for counting because people have 10 fingers. Historically, body parts were often used for counting. Even today, people learning to count or those who want to illustrate a point about counting in conversation often use fingers. Some cultures also use toes, spaces between fingers, and knuckles for counting. It is curious that numbers are represented by digits, the same word that is used to refer to fingers and toes in English and in many other languages. Roman numerals were used in the Roman Empire and in Europe until the 14th century. They're still used today in some contexts, for example on clocks, to represent the hours. You can also see Roman numerals in the name of the Pope. They're also used to name events that repeat at some frequency, for example the Olympics. Roman numerals are based on 7 numbers written with the letters of Latin alphabet. The order is important in the Roman system. A greater number followed by the smaller means that the two need to be added. On the other hand, a smaller number in front of the larger one means that the smaller number is subtracted from the larger one. For example, this number is 11, but this one is 9. The subtraction rule is not universal. It only works for numbers like these: 4, 9, 40, 90, 400, and 900. In some cases, the subtraction rules are not used, and numerals are written in succession instead. For example here, this number represents 50. An inscription in Latin with Roman numerals on Admiralty Arch in London reads, "In the 10th year of King Edward VII to Queen Victoria, from most grateful citizens, 1910. In many geographic areas, people had systems of representing numbers that are similar to the Roman or the Hindu-Arabic ones. For example, some Slavic people used the Cyrillic alphabet to represent numbers such as 1 to 9, multiples of 10, and multiples of 100. There were also special symbols for greater numbers, as well as a symbol to differentiate the numerals from the letters, similar to tilde. The Hebrew number system uses the Hebrew alphabet to represent numbers from 1 to 10, multiples of 10, as well as 100, 200, 300, and 400. The rest of the numbers are represented as multiples or sums. The Greek number system is also similar. Some cultures use similar representations, like the Babylonian system, which has only two cuneiform symbols, for 1 and for 10. The symbol for 1 somewhat resembles the letter T, while the symbol for 10 is slightly similar to the letter C. So for example, 32 would be written as shown. The Egyptian system was very similar, except that there were additional symbols for 0, 100, 1000, 10,000, 100,000 and 1 million. There were also special notations for fractions. Numbers in the Mayan culture had symbols for 0, 1 and 5. Numbers above 19 were written with the same symbols but using different orientation to differentiate them from smaller numbers. The unary system uses only one symbol to represent 1. It represents all the other numbers with the same number of symbols as its value. These symbols are usually the same, therefore if 1 is represented with the letter A, then 5 would be represented as 5 letters A in a sequence. When children learn to count, their teachers often use the unary system to help create a link between a concrete, easy-to-understand system and a more abstract representation of numbers. This system is also sometimes used in games to record the score, and for other simple calculations, such as for days or objects. The unary system is also used in computer science. Different countries may use different types of representation for this. For example, when keeping score of the winning teams or when counting items or days, people in the Western world and some other regions would often write 4 vertical lines, then cross them with a 5th horizontal line and repeat the process. In this example, the person counted to 4, crossed out the 4 lines, then counted to 4 again and crossed the new 4 lines out. People who use or have historically used Chinese characters in their writing systems, for example in China, Japan and Korea, use a certain Chinese character with 5 strokes to do the same. The sequence of drawing each stroke is not random. It is determined by the general rules for writing Chinese characters. In our example, the person counts to 5 and completes the character, and then starts a new character. The new character only has 2 strokes, meaning that the person counted to 7. Positional systems work with a base. The position of each number determines its value. The position of a number is usually called a place. The value of each number also depends on the base. The number 101 in the binary system is not equivalent to the number 101 in the base 10 system. First position is for numbers from 0 to 9. This means that the number in the first position has to be multiplied by 10 to the power of 0, which is the same as multiplying by 1. The number in the second position is multiplied by 10 to the power of 1. The number in the third position is multiplied by 10 to the power of 2, and so on, until the numbers in all positions are exhausted. To arrive at the final value of the number represented, we need to add all the values at each position. This is a convenient way of representing numbers because it allows us to work with numbers relatively large in value without using a lot of space to write them down. Binary or base 2 numeral system is widely used in mathematics and computer science. It is based on 2 characters, 0 and 1, to represent all possible numbers. In some cases, other characters such as plus and minus are also used. Numbers are represented as follows. 0 and 1 are written in Hindu-Arabic numbers as 0 and 1. From 2 onwards, the principle of addition is used. Addition in base 2 is similar to addition in base 10. To increment a number by 1, you can do the following. If the number ends in a 0, the last 0 is replaced by 1. Here, the base 10 numbers are used for comparison. For example, let us add 100, which is 4 in base 10 system, and 1, which is 1. We get 101, which is 5 in base 10 system. If the number ends with a 1 but is not all 1s, the first 0 from the right is replaced by 1, while all the ones following it on the right become zeros. For example, let us add 1011, which is 11, and 1, which is 1. We get 1100, which is 12. If the original number is all ones, then they're all changed to zeros, and a 1 is added at the front. For example, if we add 111, which is 7, and 1, which is 1, we get 1000, or 8. As you will probably notice from the explanation to follow, the addition and other operations in the binary system are analogous to those in the base 10 system. The only difference is that we're using 2 instead of 10. To add two numbers, we align them under each other. For each place, 0 plus 0 produces 0. 1 plus 0 produces 1. 1 plus 1 produces 1, 0. To represent this 1, 0, we put 0 in that position and carry 1 over to the next position. In our example, let us add 1, 1, 1, 1 and 1, 0, 1, 1. Working from the right to left, we get 1 plus 1 produces 0 with 1 carried over. 1 plus 1 plus 1 produces 1 with 1 carried over. 1 plus 1 produces 1 with 1 carried over. 1 plus 1 plus 1 produces 1 with 1 carried over. 1 plus 1 produces 10. So, putting this together, we get 1, 0, 1, 0, 1, 0. Subtraction works using the same principle, except instead of carrying over ones, we borrow ones. Multiplication is similar to base 10 multiplication. Multiplying by 0 results in a 0, while multiplying by 1 is 1. Division and calculation of square roots are also very similar to base 10. All numbers can be divided into subsets. Some of the subsets partially overlap. Negative numbers are numbers that represent a negative value. A minus sign is placed in front of them to differentiate them from the positive numbers. For example, if a person has no money and owes $500 to a credit card company, then this person has minus $500. Here, minus $500 is a negative number. Natural numbers are those that are positive, including 0, and are not fractions. For example, 7 or 86,766. Integers include 0, negative and positive numbers that are not fractions. Examples include minus 65 and 11,223. Rational numbers are numbers that can be expressed as fractions, where the denominator is a natural number that is not 0 and the numerator is an integer. For example, both 3/4 and minus 10/5, which is the same as minus 2, are rational numbers. Complex numbers are all numbers that are a sum of one real number and a product of another real number and the imaginary unit I. Here, I is the imaginary unit, which satisfies the equation of I squared equals minus 1. It is also sometimes called an imaginary number. We can write our complex number as A plus BI. Here, A is the real part and B is called the imaginary part of the complex number. Prime numbers are natural numbers greater than 1 that produce an integer only when divided by 1 or by itself. Some examples are 3, 5, and 11. 2 to the power of 57,885,161 minus 1 is the largest known prime number as of winter 2013. It contains 17,425,170 digits. Prime numbers are used in public key cryptography. This is a system of encoding data often used in online secure data exchange, such as in online banking, online shopping, and in electronic wallets. Now, let's discuss some interesting facts about numbers. To prevent fraud when writing numbers in business and commerce, Chinese language uses special complex characters that are difficult to forge by adding extra strokes. This is done because the commonly used Chinese characters for numbers are too simple, and it is easy to modify their value by adding strokes. Checks and other financial documents use the special, more complicated characters. Some languages in countries where base 10 is currently used still reflect that other number systems were common in the past. For example, English has a special word for 12, dozen. Currently, it is used mainly for counting eggs, baked goods, wine, and flowers. Khmer has special words based on the ancient base 20 system to count fruit. In the Western tradition, the number 13 is considered to be unlucky. Many believe that this is carried from the Judeo-Christian tradition, where 13 was the number of Jesus Christ's disciples during the Last Supper, after which the 13th disciple, Judas, betrayed Jesus. There was also a superstition among the Vikings that when 13 people gather, one will die the next year. In Russia and many of the former Soviet countries, all even numbers are considered unlucky. Possibly, this tradition originated from the belief of early Slavs that even numbers are complete, stable and static, unmoving, and thus not alive. Odd numbers, on the other hand, represent change, motion, an entity that needs completion and progression, and thus life. According to this belief, it is considered bad luck to give an even number of flowers to living people. Instead, even numbers are usually reserved for funerals. In the Western world, on the other hand, it is acceptable to give an odd number of flowers as a present. And in fact, flowers are often counted in dozens. In Chinese, Japanese, and Korean-speaking countries, number 4 is considered to be unlucky because it is pronounced the same way as death. In some instances, all numbers that have a 4 in them are considered unlucky. For example, a building may not have floors 4, 14, 24, and so on. In China, number 7 is also unlucky because it represents the spiritual world and ghosts. The 7th month in the Chinese calendar is referred to as the ghost month, when the connection between the world of the living and the spirits is open. In Japan, the other unlucky number is 9 because it has the same pronunciation as suffering. In Italy, 17 is an unlucky number because when its Roman numeral representation is rearranged, it reads vixi, translated from Latin as I have lived. This implies that one's life is over and refers to death. In fact, vixi has often been written on graves of ancient Romans. 666 is another infamous unlucky number, called the number of the beast in the Bible. It is sometimes believed that the number of the beast is 616, but 666 is more common. It refers to the Antichrist or Satan, and some believe that the Antichrist will be marked with this number. Its origins are debatable, but some scholars believe that 666 is the transliteration into Hebrew and 616 transliteration into Latin of the name of the Roman Emperor Nero. He is associated with persecutions of Christians and known for his tyrannical and bloody reign. Given this history, it is not surprising that Nero may have served as an inspiration for the discourse on the number of the beast. Nero is also thought by some to be the arsonist during the Great Fire of Rome, although his involvement is debated by historians. Thank you for watching. If you liked this video, please don't forget to subscribe to our channel.